Welcome to Get Your FRQ On. This question is from the 2003 B exam. It's question 1 and it is calculator active. In the question stem, we have a function f of x and a line which is tangent to the graph of f of x somewhere. We also have two regions, one of which, R, is defined to be the region bounded between the graph of f and the x-axis, and the region S, which is the region bounded by that line, the graph of f of x, and the x-axis. In part A of the question, we are asked to show that the given line is in fact tangent to f of x, specifically at x equals 3. There's a number of ways to do this. Essentially what you're going to have to do is show that the line goes through the same point on f of x when x is equal to 3, and show that the tangent line at that point has the same slope as the given line, which would make the tangent line the given line. All right, so the way I did this, I just calculated f of 3. I put f of 3 into the function f. F of 3 turns out to be 9. And notice that if you plug in 3 into the equation for the given line, you also get 9. So at the very least, we know that the graph of f of x and that given line intersect at 3, 9. Now what we haven't done yet is shown that the two lines have the same slope. Once we do that, we've shown that the given line is in fact tangent to f at x equals 3. Now, because we have the function f of x, we can find its derivative. F prime of x is 8x minus 3x squared. And if I evaluate f prime of 3, I can just plug 3 into f prime of x. That turns out to be negative 3. And that is exactly the slope of the given line. So the tangent line to f of x at x equals 3 and the given line are in fact the same line. Therefore, the given line is tangent to f at x equals 3. In part B, we are asked to find the area of the region S. This is going to get tricky. Right? The region S is bounded above by the given line L and below by the graph of f of x, but not everywhere. At some point, the graph of f is no longer involved, and then we just have a region bounded by the given line and the x-axis. So this is going to be very tricky to do with one integral. Going to have to split this up into two separate integrals. All right, so in order to do that, we have to know what is the x-intercept of that line, what is the x-intercept of the function f of x, where do our bounds of integration change, right? So the x-intercept of the given line is pretty easy to show. It's just 6. The point where f of x is equal to 0 is the solution to the equation 4x squared minus x cubed equals 0. That's easy enough to factor by hand. We have x squared times 4 minus x, so that's 0 when x is 0 or 4. And I think given the context, it's pretty obvious we are interested in the value x equals 4. So we have two integrals. We have the integral from 3 to 4, where the line that's given to us is tangent to, and therefore intersects, f of x. 18 minus 3x minus f of x, plus an additional integral from 4 to 6 of just the line 18 minus 3x dx. All right, now since this is a calculator active question, we can do these integrals using our calculator. The second one, the integral from 4 to 6, that's just a triangle. That area you can do pretty easily. That's just 6. But the integral from 3 to 4 of 18 minus 3x minus 4x squared minus x cubed dx, that one you're probably going to want to use a calculator for. Not necessarily. It can be done without one. But it's just going to be quicker to use a calculator on that integral. And it turns out the total combined area is 7.917. So that is the area of S. Kind of a tricky integral problem. In part C of this question, we are asked to find the volume when the region R is rotated around the x-axis. Now, since we're rotating around the x-axis, we're going to integrate with respect to x, but that volume, this is going to be volume by disks, or the disk method. It's going to be pi times the integral from 0 to 4 of my f of x function is the radius, so I have to square that to get the area of a circle. So we have the integral from 0 to 4 times the square of 4x squared minus x cubed dx times pi, and that turns out to be 490.208.